All right, now we're going to look at solving multi-step equations by looking at a challenge and looking at a real-world connection as well. All right, so pause the video after you take a look at these. Maybe try them on your own first, but then let's go ahead and go through them together. So the first one that I want to look at here is this one on the left. It looks like what makes it challenging is the fractions that we're being given. And in an earlier video, I showed that you can multiply through both sides by 15. The 5 times the 3 gave us the 15. Here I want to model doing this by getting common denominators as well. So I want you to remind you about common denominators where we have a target denominator which is a common multiple of 5 and 3. Usually we look for the least common multiple, although that's not mandatory. And the other thing to remember is that you can always multiply any individual piece of an equation by any special version of 1, and it won't change the equation as a whole. It's not something that you need to do to both sides. We're really just taking individual pieces of the equation and multiplying by special versions of 1. So let's look at this. I'm going to multiply this by a 5 over 5. That's a special version of 1. It doesn't change the equation as a whole. And I'm going to multiply this guy by 3 over 3, another special version of 1. Okay, so let's see what that does once we multiply through. Remember, multiplying fractions, we're going to multiply straight across the top. 5 times 16 is 80. And we're going to multiply straight across the bottom. And I'm seeing I made a clear mistake right now. So I'm going to keep that mistake on the video. I think it's good to show us math teachers making mistakes as well. I'm going to erase some of this. I think you can see I wouldn't have gotten common denominators. I switched the numbers I needed to multiply. I would have gotten a denominator of 25 and a denominator of 9. So let's redo that in a correct way. Totally okay to make some mistakes here. I'm going to multiply this guy by 3 over 3 and this guy by 5 over 5. So hopefully that gets us a little more progress on the right track here. And again, multiplying straight across the top, we have a 48 over 15 minus 4x times 5 is 20x over 15. Yay, we got common denominators. Equals negative 2 over 15. Okay, so that we got there eventually on that one, so that's good. What I want to show next is we could simplify the denominators, but why not just multiply everything through by 15 here? And that will wipe out all the denominators. Multiply everything through by 15. And we end up with a 48 minus 20x equals negative 2. I'm going to go a little bit quicker here to solve this guy. Let's subtract 48 from both sides. I have a negative 20x equals negative 50. And let's divide by negative 20. X equals negative 50 over negative 20, which is 2.5. So there's my solution right there. To keep my video not too long, I'm going to go through the check of this off screen, but we did get the correct answer right there of 2.5. Okay, next one, let's look at a real-world connection. And this, again, has some truth to it. I did rent a truck for a day to move some things from a storage locker back into my house after living abroad for a year. The truck company charges me $24.99 a day, so that's a flat rate. And I'm just going to need it for one day, so I know I will just need to pay that $24.99 for just one day. However, also they're charging me 49 cents a mile, and I need to return the truck with a full gas tank. Gas these days is about $2.50 per gallon, and I learned that the truck gets a mileage of about 12 miles per gallon. And I have a budget of $100. How many miles can I drive? This is a little bit of a tricky one at first, particularly because there is a per day, there's a per mile, and there's a per gallon, all wrapped into the same problem. And when I'm stuck on something like this, I actually look for the actual question mark. Here's the question mark, and it's saying how many miles can I drive? And that tells me what my x is going to be. X is what I don't know. X is what I'm being asked. X is number of miles. All right, and the other challenge here is a couple things in gallons, and then a couple things in miles as well. Okay, and this is mileage per gallon, 12 miles per gallon. So just again, these overlapping units. What I think I want to do here is I want to look at what's the cost in gasoline of 1 mile. And I'm going to do that first. So if it costs me $2.50 in gas to go to use 1 gallon of gas, which gets me 12 miles, I can see the cost of exactly getting of gas in driving 1 mile. And so that is going to be, I'm going to round to 2 decimal places, 21 cents. Okay, so that's the cost in gas of 1 mile. Okay, and so looks like I can start writing out my equation right now. I know something is going to equal $100. That's my budget. I know I have a $24.99 flat fee that no matter what I have to pay. And then I have actually 2 different charges per mile. I have 49 cents per mile that the rental company charges me, and I have a 21 cents per mile that I'll need to be paying in gas. It looks like we have an equation set up. Let's go ahead and do some simplifying and solving. These two guys combined together give us 0.70x, so that means all told I'm paying 70 cents for every mile I drive. Plus $24.99 is 100. I have everything written down, simplified as much as possible. And let's go ahead and solve this guy. Subtract $24.99 from both sides. And we have 0.70x is equal to, what is that, $75.01. And then as our last step, we can divide by 0.70. And that is going to cancel out that on the left. And let's do that division on my calculator here. Looks like I get a 107.16. And maybe you see the mistake I just made. X up here is a number of miles. I drew in a little dollar sign. X is not dollars, X is miles. So we can drive 107 miles. Okay, that's a good place to stop right there.